Alright, so, camera obscura. We talked about camera obscura being a box, a dark room, okay, which we created next door. Okay, what we're going to start to talk about now is a camera, modern day camera, and we're going to look at the parts, the components that make that camera. We compare that to the camera obscura, which is what we made 4 days ago. Camera obscura basically has all the parts that you need for a camera. The only thing missing, and what was the thing that the Renaissance artists added to camera obscura, was someone to record the image, right? Camera obscura has a hole, it has light coming in through the hole, it's transferred into a dark room to contain that light, and then it's transferred onto the white card or whatever it is. The recording, the keeping of that image is the person drawing on that image, right? And recording that thing. And whether it's a stand-up inside thing, or if it was there's a box that you probably would have seen in one of the tutorials, in one of the lessons. There's a box where they kind of flip it up and it reflects up when they draw, okay? So all of those things are essentially the same as what we just did, which is the same as a camera. We're going to look at a camera and we're going to talk about what makes a camera. So the first thing we had, look at a camera, is we have a dark blue. In our case, a box. Okay, so every camera is a box. And in that box, we've got a little hole that lets light in. Okay? Now, we're going to look at there are obviously a number of different cameras. We're talking about a DSLR. We're going to look at DSLR and we're going to look at a medium format camera, which I have here. I like the medium format because we can actually take it apart and see all the component parts, composite parts, so that you can get a sense of what I'm talking about. Because when I draw it on the board, it gets a little bit like abstract. Kind of what's going on there? So, box, hole in the side, light comes in. So here's my Christmas tree outside. Before you draw a Christmas tree. Okay. Now we remember that the sun, our light source, does this, and light bounces in every which way, in every direction, like this. Okay, and some of that light makes it in to here, and if it bounces here, it makes it in here in a camera obscura. Now we're not talking camera obscura, but the same principles apply. Okay, we have a hole that lets light in. With a typical camera these days, instead of that hole just being a cutout in a piece of cardboard, we have a lens that attaches to the front of the camera. Okay? Now, inside this lens, there are a bunch of pieces that we're going to talk about. We'll break it down and talk about some of those. But essentially, for lack of any more scientific terms, we've got a bunch of bent up glass, bendy glass, okay? Lenses. And if you did grade 10 optics, you will have learned a little bit about lenses and what they do. And there's a bunch of pieces in there. Do I know what's inside of that thing? No. Glass, lenses, stuff. Okay? So, light goes in here. Now the light path obviously does this, right? It goes into the camera, it goes through here, and it enters that box. The lenses simply do some refracting or I don't know, magic, okay? There's a bunch of parts where I will point out where magic is, okay? Magic is the green arrows. There's magic in there, okay? Yeah. Magic is green. Alright, so one important part on this is, and we'll just kind of draw it here. I don't even know actually where it is. But there's a part here that matters. And that part, and I'm just going to do this with it so we can sort of separate it, is an important term we need to know. Aperture. Okay, aperture, right? An aperture is like curtains, for lack of a better example. Okay, it basically lets light in or lets light not in. Right? I can have my curtains open or closed or halfway or whatever, and that's more or less light in. So all cameras have an aperture, and they allow light to come into the camera. Right? Now the way that works is, and you may have seen this sort of image before, but there's, right, I'm looking at the lens from the front, and then there's going to be, they're called Aperture Blades that basically do this. It sort of looks like a portal from any kind of space movie you've seen where an alien comes out. And what happens is as those blades get closer, it makes a smaller hole, and as they get further away, it makes a bigger hole. So, we'll see that the blade can also do this kind of thing. Now this is a very technical drawing. You can't reproduce something as technical and accurate as this. I don't expect you to be as good as the teacher is. But anyways, this is the technical term. This is bigger than that is. Okay? What happens? I'll give you time to write this down after, okay? I'll give you a chance to. Okay? Now what's going to happen with light going through a bigger hole? More or less light? Any answers? Anybody? More or less? More. Beautiful. Okay. So if you can do the following for me, I want you to get close to, like in groups of sort of 3 or 4. This is a very informal thing. Get into groups of 3 or 4, and I want you to find the person who's got the lightest eyes in your group. Now, if you've all got dark eyes, mix someone in who's got light eyes.
Try not to get lost, right?
Try not to get lost in my light. Okay, get into groups of 3 or 4, doesn't matter, and have someone in your group who's got light eyes. Our viewers at home. Come on over here. Wait. I'll move this out of the way.
Hold on.
Alright, so what I'm going to do is I'm going to take my phone, I'm going to go my flashlight app. Alright, I'm going to get someone with light eyes. Now you can do this in groups of 4 or 5 or 3 or 2, whatever, it doesn't matter. You just want someone with light eyes. What you're going to see is you're going to see an aperture working. So let me turn on my flashlight. Alright, come on over here. Alright, so what I'm going to do is I'm going to, now you don't need a flashlight. You can actually do this by looking at the light. But look up at, so everyone can sort of see where your eyes are. Look up a little bit. Okay, I'm going to do this. And what you can see his pupils dilating? That's really bright, isn't it?
Yeah.
Sorry. Can you see that happening though? Okay, so what's happening there, you probably have seen that. Pardon?
This experiment is going to blind people.
That's right. Right. Sorry, I didn't even pay attention to how bright that was. I'm sorry. So what's happening there is the aperture in his eye, the pupil, is opening and closing. Now you can actually do that by these work as a pair, okay? And so what happens if you cover one and look up at a light and then take it away, both of them will constrict. When you go to the doctor and the doctor covers your eye and says, he does this sort of thing, he's trying to see, right? That happens, yeah, right? Don't they do that?
Not
right?
really, but it's okay.
Sure they do. Optometrists do it all the time, right? They do this and they're like, right, They're trying to see if they're going together, because if they don't go together, you're having a stroke.
And when doctors do that, like brain surgeons do that when they're checking the brain
Yeah,
activity.
just to make sure that you're still all there. All the pieces are still there.
Obviously,
Right? Because we're together. Okay? All right, so if you want, I'll give you 2 seconds to find someone with light eyes. You don't actually have to do it with a flashlight. That's actually kind of But you can do it just looking into a light. You can just sort of do this, cover it up, and then try that. Okay? I'll give you 1 second to do that. And we're back. Okay. So, what was I saying? I was saying, right, sometimes you go into a dark room and your eyes, they need time to adjust. Well, what's happening is the adjustment is that those pupils are dilating, allowing more light in, right, to capture to your sensors, which are in the back of your eye, the image that is being projected into them. Okay? Right. So that's aperture, and that happens up here. That happens before the light enters the room. I'm going to move the camera. Okay? Questions so far? Great. All right, so that's an important part. Now, the light path goes through the bendy glass, and then it goes onto what is, for all intents and purposes, I'm going to refer to this as the mirror/shutter. They're the same they're actually not the same, but for our purposes, I'll refer to them as one thing. So when I talk about the mirror, I'm talking about the shutter. When I talk about the shutter, I'm talking about the mirror. Essentially, the shutter, or the mirror, we'll call them shutter for now, is this. All right, my eyes are closed. No light is getting in right now. No matter how wide or narrow my pupils are, no light's getting in, because I've got a shutter in front of them that is blocking the light path. Yes? Yes. Now, this is blocking the light path because it goes, and pay attention to the light path because it shows up on a test, it goes this way, and where it has to get is to the sensor. The sensor, or sensitized material, is back here. Let's start labeling things. Now for short we'll call it sensor, but it's actually sensitized material because we're using a digital sensor and a digital camera, but in some cameras we use film, right? And the film is sensitized material, it's not actually a sensor. Film is usually a plastic roll, and on that plastic roll is sprayed a chemical that is photosensitive, right? Like the silver nitrate that was used 100 years ago, okay? All right. Sensitized material, sensor. This is the mirror slash shutter, and I'll use those even though they're not identically, I'll use them interchangeably. Now, what's happening is because this light hits this mirror, does it make it to the sensor? No. What happens to it? Because it's a mirror? Bounces it up. Now on top of a camera, here. This one doesn't have a lens on it for a reason, but on top of the camera there's this little thing here, this sort of section, right? Now that's where the camera is, that's the room, and I would have a lens here but I don't, but anyways, and then there's this thing up here and there's sort of a viewfinder back here. What's happening with that light is that it bounces up, it goes into this section here, okay? And in here is something called a prism, or a crystal, depending on who you ask. The term is basically interchangeable. So again, I'll write prism or crystal. Okay? And what happens in there, again, magic. Okay, so I'll put a green arrow. Magic be here. There's magic, and here's magic. There's magic. Okay? Bounces it around a little bit. If you remember in the camera obscura room, the image was flipped and upside down, right? It was flipped and upside down. So we want to look through a camera and we don't want to see it flipped and upside down. We want to see it the right way up. So the prism does that. It magically makes it small enough to view and flips it a couple times to get it so it's viewable. Okay? And then it does this magic and then comes out this way to your eyeball. And there you have beautiful eyes. Okay? That's you. Good so far. Questions? Making sense so far?
Yeah.
Alright, so there's our light path to here. Now what happens? We need to take a picture. And so, for the light to go from here to this thing, which is our sensitized material, the thing that's going to store our image, because right now all we've got is a camera obscura. We've got a camera obscura which is projecting light into the box. Okay, now this is sort of an extra piece that we don't have in a room, but essentially this is a camera obscura. Here's what's missing, and this is Leonardo da Vinci, almost said DiCaprio. Da Vinci. Leonardo DiCaprio. Draw me like you French girls, wearing this and this. Okay, this is, that's pretty fast, eh? Alright, so this is blocking the light path, and we need, pay attention to this because this shows up on the test. The light path needs to go here. This is where the image is going to be stored. Okay? And right now it's not doing that because it's being...
Mr. St.Romain.
Hello?
Can I please see Ren and guidance?
Who?
Ren Siskar, Chelsea.
Yes. On our way.
Thank you.
Yep. I had Brent. Brent graduated 2 years ago. Thanks. All right, so that is what needs to happen. Right before, luckily, Ren, you can just watch the video later. Hi, Ren. See? Anyway, so light has to go from here into here because this is where we store the image. Now, if we're using film, it stores it to the film. If we're using a digital sensor, it stores it to the digital sensor, and I'll talk about that in a moment. But this has to happen. So what happens here is when we press the shutter button, okay, the shutter or the shutter release button, which is the button on top of the camera, which is, you know, the right? That sound, not that sound, but that sound, is this thing moving up and out of the way and then dropping back. So it goes. Okay, now, depending on how long you've set your shutter speed, which is another term that we're going to pay attention to, because we're going to talk about this soon, shutter speed. That shutter, that is either going to be fast, like this, or slow, like this. Okay, want me to do that again slowly for you?
Yeah.
Fast is like this, and slow is like this. Fast.
Wow.
Slow. Teacher of the year. All right. So,
I don't
So,
like the other one.
sensible?
Well, I don't like the stripe.
Why do we care about shutter speed? Well, everybody close your eyes and look at me. I know that sounds weird. Look in this direction. Look in this direction and close your eyes. That's probably a more clear description of what I want you to do. All right, I am going to be walking across the class. I'm going to start on one side, and I'm going to start walking. And I'm going to ask you, while you're looking in this direction, I'm going to ask you to open your eyes and then close them again. Okay, so with your eyes closed, looking in this direction, Okay, pick a spot roughly on the board, kind of where I was standing. And eyes closed, everybody, everybody. Okay, looking towards that same direction. Okay, I'm gonna walk, I'm walking. And I say open, close. Ready? Open, closed. Okay. Open again. I traveled from like here to what, about here?
Yeah.
Right? Okay. Do it again. Eyes closed. Let's see how long it would take before we finish that. Okay, eyes closed. Walking, walking. Open. Closed. Okay, that was a much longer shutter speed. Yes? I made it further. I had time to do this. I made it further in that time. This was half a second or so. This was two very poorly drawn seconds. 2 seconds. Now, in photography terms, these are both extremely long times. Okay? If I can go from here to here, your photo is probably ruined, most likely. Unless you're purposely trying to show movement. We talk in terms of like 1/60th of a second is considered getting towards fast. Okay, so a second, so now divide it into 60 pieces in one of those. Okay, that's fast. That's like, not fast. What is this? Not fast. Okay? That was exactly 1/60th. Okay? Anything faster than that, 1/60th, 1/25th, 1/250th, 1/500th, 1/1000th, those are fast. Okay, 1/1000th of a second. So take a second, and then take your second and split it up into a number of seconds, little sections. Okay, all right, 1,000 sections. Try that 10 times fast. 1,000 sections.
So you got me
Sorry?
section, 1,000.
You didn't know I used to do stand-up comedy?
1,000 sections.
I did.
1,000 seconds.
I didn't. Anyways, moving on. So, 1,000 sections, that's 1,000th of a second. Okay? And that's what we're talking about. That's fast. Okay, 1/500th is fast, 1/250th is fast, 1/125th is fast, 60th is fast. Any slower than that is, in photography terms, is considered slow. Okay, 1/30th of a second, that's actually fairly long in photo terms. Okay? And we'll look at those numbers in a minute. Alright, so far we're talking about shutter speed. Now who cares? Why would I ever want something to be long like this, or with a long shutter speed? Well, let's think about this aperture, this pupil that's letting light in. Right? In this room, we have enough light to get enough light.
That's going to be fun.
I'll just edit it together. And we're back. All right, so. Whatever I was just saying was probably something about shutter speed.
Why do we want it to be that long?
Right, why do we care? Why would I ever want an image to be that long? Well, so if I... Okay, so if I want a long shutter speed, that's because I want to let light in for a longer time. Now that may be for artistic reasons, or it might be because there is not enough light present. Okay, so if it's evening, nighttime, and I open my shutter for a quick second, right, I go like this, and close them again, that's not enough light to register. Think about going into a dark room at night, and opening your eyes and closing them. Your eyes are not going to have enough time to adjust. Now that's not exactly the right metaphor, but kind of makes a little bit of sense. Okay, you want to let in more light, and we'll talk about balancing that in a few moments. So far we care about aperture, how big this hole is, and shutter speed, how long it's open for. Okay, so I'm going to draw a little timer. Okay? So far with me?
Yes.
Yep.
Questions so far? Good. Okay, so we have light path. This goes, opens up. Once it's open for 1/60th or 1/25th or whatever it is, however long it's open, light transfers to our sensor. The sensor has to remember what it sees. Now, we're going to get into, I'll try and explain. You don't need to know the like the details of it. You just have to have a sense of what I'm talking about. A sensor kind of comes in two formats. I'm going to erase this. Am I still in front there? I'm good? So, a sensor sort of comes in two formats that we care about. Film and digital sensor. okay? Digitized sensor for, or digitized material for film is that little piece of plastic with digitized, or with sensitized material on it. It's photosensitive and records. A digital sensor is slightly different, and I'll explain that in a second. We have another control that we care about called ISO. Not iOS, ISO. People will mix that up 100 times. iOS is for your phone, ISO is for your camera. Okay? ISO, and it refers to how sensitive your film is. Now, if you remember the days of film photography, which you may or may not, film came in a set of numbers. 100 was like the basic, 200 was the basic. These are kind of the most common forms of film. And in the days when you got a roll film, it would say 24 exposures, 120 or 100 ISO or 200 ISO. Okay, and then we had 400 and 800 for more specialty photography, and then we went up to 1600 and 3200. Now, what this means is low sensitivity, high sensitivity. Now, we don't always need high sensitivity. Generally, if it's sunny outside, even on a day like this with the snow, it's bright enough, it's going to be bright enough to use like 100 ISO. Okay, that's the least sensitive of the films. Okay, 3200, this is for like night photography. And at nighttime, you need more sensitivity because it's not as bright, so it's not as much light to write with or to capture with. Okay, that makes sense? Okay, so the ISO setting for film used to be relevant to the film. Now it's relevant to the camera, and we'll talk about how it changed and what it's doing. But essentially, these are some numbers you should know, and they basically double. They do double. Okay? Newer digital cameras can exceed this by a lot. Even ours, which is not a high-end camera, 6400, and I think now they're up to something like 52,000 or something. You know? I don't know what the highest. I don't even know. But it goes, for our intents and purposes.
Would it be like 120?
Sorry?
Would it be 120?
I think it goes like the 50,000 or something. I don't even know. I don't know. Or no, more than that. I don't know. I don't know. No. It goes higher than that. Let's put a little arrow more. Okay? Okay. This is plenty for evening and night photography. The issue, quote unquote issue that you're going to find is shooting night photography at 3200 ISO is going to give your images something called
Mr. St.Romain.
wrong. Yes?
Sorry to interrupt again, but can I see John Stephen and Tess Wang?
John Stephen and
Tess Wang?
not in this class.
I think she just joined your class. No? Oh, never mind. No, she's not. So just John Stephen.
Okay,
Thanks.
he's on his way. Where?
Sorry, got it.
Guidance. Okay.
Thank
All right.
you.
You're welcome. Okay. Yes.
Use the bathroom real quick.
Yep. Okay. So, ISO. What was I saying?
You ask us what something's called.
Yeah. If you take a picture at night.
Right. Film grain. Okay, so if you take a picture at night, sometimes you may have seen this in photos taken in the evening, that there's like little dots, almost like pixelation on the image. Okay? It's actually not pixelation, it's called film grain. And that happens because if we think about, so here's our film, our exposure. Okay, and I'll just do these little squares just so that we know that we're looking at a piece of film. Just to, I don't know. These are really bad squares. Anyways, that's film. And on the film, they spray this stuff. We'll call it silver nitrate, but it's not. It doesn't matter. Sensitized material. It gets sprayed on here. It's photosensitive, and it basically gets sprayed on at a certain density. And if it's like, this is again very scientific. These dots are, I'm specifically putting them in the exact locations. I know it really well, which is why I can do it when I'm not looking. Alright. Okay. So, if it's this dense, if it's sprayed on this densely, it's going to be less sensitive because there's less of it. If it's sprayed on more densely, like that, it's going to be like 800. And if it's like that dense, which is, you can tell, it's more dense than, so there's more of it. We're getting into the higher end. Now, this is basically the thing that makes it sensitive. So more of it makes it more sensitive. Less of it makes it less sensitive. Why? Because it's daytime out. So you don't need to really worry about it because there's so much light, you don't need to be as sensitive. Whereas when it's nighttime out, who would have thought you'd get photography and rap art in one class? Okay. This is less light because it's nighttime, and so we need more of this to be sensitive enough to capture the image. Make sense? Questions? Good. All right. So these are numbers you'll need to know. Film grain is something, and basically what happens here is like the reason we get film grain, and for I don't know if this is actually accurate, but I think it explains pretty well. There's a lot of them, but they don't really know what they're looking at all the time. They're kind of dumb. So they look and they're like, oh, I see red, and then they kind of check with all their friends. They're like, do you see red? I see red. Yes, red. Can we all agree on red? Okay, we all see red. So all of these guys are like, yeah, we all see red. And you see that clump of red as one thing, because they all agree. They're all like, yes, we see. I'm going to throw harder every time. Yeah.
Pour water on it.
Yeah. Okay, so more of this higher density is a higher ISO, and they don't really communicate with each other, but for lack of a better explanation, they communicate with each other, and they all see the same, so you end up seeing little clumps that make film grain. Okay? Great. Now, do you need to know that specifically? No, but it's good to kind of know what we're talking about. You do need to know what this is. Okay? And that it appears at higher ISOs. It doesn't appear here. You also have to know that daylight, because it's bright, is going to have enough light that you don't need a highly sensitive ISO. Nighttime, when there's not enough light, you're going to need a higher ISO because you don't have enough light to make your image work.
Wait,
Yeah.
so is there more film grain the more like?
The higher the ISO number, the more film grain, yes. You won't get film grain here. So I'll write this. Film grain, yes. Film grain, no. Okay? Questions so far? I think the last thing I said was questions. Questions? Okay. All right, so I think that sort of explains this situation fairly well. Now, what's missing from here is digital sensor. So digital sensor works sort of like an LED TV, except an LED TV, if I get close enough to that TV and I'm going to put my face right up to it, I'll see little dots, right? Because on an LED TV, here, I'm going to do this, and this is a magnifying glass. This is magnifying my view. Art. And at this level, if I get close enough, you see there's these little like lights, little LED lights. And this is probably not at all what they look like, but for the sake of my classroom, which is not a science classroom, this is what they look like. Exactly. Okay, there's a bunch of these, right? And they kind of look like a bunch of lights. And I get close enough, I can see like red and blue and green. You ever done that to a TV? Kind of really close and you can see the lights? Okay. That's what an LED TV is doing. Little lights that make up your colors based on red, green, and blue, right? Okay. Except we're not talking about camera light going this way off of the TV. It's actually going the opposite way, and there are little sensors, and these sensors simply record in reverse of what this is doing. This is like emitting light. This is capturing. Okay, so like little light sponges that capture the image and the light that's there, and they remember. Okay? So a digital sensor just remembers the light that it sees and transfers it to a pixel grid. But that's overly complicated. All you have to know is that this is absorbing light to a sensor, which it remembers, as opposed to emitting light, like an LED would. Okay. Does that make sense? It's a little bit weird. Anyone find that hard to follow, or people are okay with this? Anybody? I'll see this. When I ask that question, people are like, Come and see me if you don't understand. And actually, there's a website, a link on the site that repeats this whole thing. Another guy does a tutorial very similar to this. In fact, this is based on that. That explains it again. So if you want to watch it again, there's a link on the website. And I'll probably post this video. Okay, so that's a digital sensor, which is doing the same idea as this. The only thing is, you can't change the number of sensors on here. The number of sensors is set. What you can change is how much power. This is a Duracell battery. Okay? How much power is going to this thing? Okay? So if I go 2 times the power, so at regular power it's going to be 100 ISO. Am I still in frame here?
No.
Barely.
Barely? Okay. Come back over here. So, how about that? Is that it?
Yeah, that's it.
Okay. So, this is the sensor. That's the sensor. At regular strength, it's going to be 100 ISO. If I double the power of the battery, it's going to be 200 ISO, and so on. So it just keeps on doubling the battery power and adding more sensitivity to that sensor, trying to remember what it sees. I think that's enough. It's a lot of talking for me, okay? But I like to do it all in one go, just because it's sort of a lot to take in, and if I start and stop and start and stop, like these suckers, you don't necessarily get enough, okay? You're gonna have to think about this and sort of, I think, kind of metabolize the information, whatever, take that on and sort of figure it out. I suggest going to the website and watching the video that does this. There's an image, and I'll tell you the section, in one section, in a second. Okay, under 2.1, so under units 2.1, getting to know the camera. Video 2.1 is how a camera works. You click on that, and it does this same tutorial, possibly better than I did it. Okay, it might explain it a little bit better. Good to get 2 people views. Yeah.
In grade 10 Comtech, you showed us this website where you could like play with all the settings. Or we're gonna do that?
Okay. I think that's all I want to do. I do, however, I'm going to stop this. So, everyone say bye, class.
Bye, class. Bye, Boise.